Good morning friends. Today we are going to discuss about the queue data structure and its implementation using arrays and the linked list. The queue is a special kind of data structure or the list where the items are inserted at one end and the elements are removed from the other end. The elements are inserted from the end called as rear and the elements are removed from the end called as front. Another name that we can give for the queue is first in first out list or first in first out data structure. So the operations on this queue are somewhat similar to that of the stack, but only the difference is that the place where we are inserting and deleting. So the two operations that we are implementing on the queue are enqueue and dequeue, and we can also call them as insert and delete operations. Enqueue operation is used to insert an element at the end of the queue, and the dequeue is the operation that is used to delete an element from the starting of the queue. The queue data structure is somewhat similar to that of the general queues what we are seeing in the near the cinema theaters or anything. So suppose consider that a person who is entering into the queue, he will be entering into the queue at the rear end of the queue, and the element or the person that is coming out of the queue will be coming from the front of the queue. In a similar fashion, the queue data structure is also implemented where the elements are inserted at the rear end of the queue and the elements are removed from the front end of the queue. And how this queue is implemented? We can implement the queues in two ways. One is the static implementation and the second one is the dynamic implementation. So using the static implementation, we can use arrays for implementation of the queues, and the dynamic implementation of the queues, that is by using the linked list, we can implement these things. At first we will see the array implementation of the queues and how these operations are implemented on these queues. As an example, consider that the queue will be having the fixed size, so we can't insert more than that particular thing. So that's why in the queue we are getting the two conditions. One is the queue is full, another one is the queue is empty. When there were no elements in the queue, we can specify that the rear and the front is pointing to the -1 because the index will be starting from 0 for the arrays. And whenever the queue is full, that means the rear side what we are using is at maximum size -1. That is 0 to maximum size -1 is maximum number of elements that are present. So initially the front and the rear will be present at -1. Whenever I want to insert an element 10, that is I am implementing the enqueue operation for inserting a 10, the front and the rear will become as a 0 because this is the first element of the queue and this is the last element of the queue. So front and rear will be pointing to this one. Whenever I want to insert at the 20, the rear is incremented by 1. That is, rear is equivalent to rear plus 1, and I am inserting the position there. This is the front of the queue, and this is the ending of the queue. And suppose consider that I want to insert 30, 40, 50 using the enqueue operations. So 30 is inserted by incrementing the rear, 40 is inserted by incrementing the rear, and 50 is inserted by incrementing the rear. So front is at 0 and rear is at 4. If I want to insert the 60, rear is incremented by 1 and the 60 is inserted in the fifth index position of the array. So like this we are using the enqueue operation. Now the basic conditions that we are having for implementing this particular queues is, so we'll see with an analogy for this one. Suppose consider that you are entering into a theater queue to take the ticket to enter into the queue. So generally, when I want to enter into the queue, that is when I want to enqueue this one, suppose consider that no person is there in the queue. That means the front and the rear is -1. When you are entering into that particular queue, you are the first person and you are the last person. That is front and rear is equivalent to 0. That is one condition. And the second one, suppose consider that 4 persons are in the queue. You are the next person to enter. That means you are the fifth person, 4 plus 1. That is rare plus 1 and you are entering from the back of the queue. And suppose consider that you want to enter into the queue, but there was a maximum limit for the queue. If the maximum limit has been reached, they'll tell that the queue is already full, you can't enter into this one. So that's why the three conditions for inserting the elements into the queue are: one is when the queue is empty, what you are doing. The second one is when some people are present, what is the thing that you are doing. And the last one is when the queue is full, what are the activities that we are doing. We'll see that in the algorithm. So I want to read an element to insert in this one. So whenever the rare is at maximum minus 1, that is rare is at maximum minus 1 means already the maximum number of elements have been inserted into the queue. You can't insert more elements. That's why you are displaying queue is full. Or otherwise, suppose consider that queue is empty. That is, no one is there in the queue. Front is minus 1 and rear is minus 1. You are the first person to enter into that particular queue. So front is equivalent to rear is equivalent to queue, because that is the first element and that is the last element. Otherwise, some people are present in the queue. Then you are incrementing rear by 1 and in the queue of rear you are entering that particular element. These are the three conditions that we are having for this particular enqueue operation. This we can see as a function also. I am reading the number. When the rear is maximum minus 1, you are telling that queue overflow. Otherwise, you are finding out whether the front is equivalent to minus 1, that is, it is empty, then front is made as a 0. And rear is equivalent to rear plus 1, and in the queue of rear, you are placing that particular number. And second operation that we are going to see is dequeue. So the dequeue operation will remove the element from the front of the queue. That is, suppose consider that we are having the 5 elements. Suppose I want to implement the dequeue operation. It will remove the 10. Next time, once again you are removing the dequeue. The front is incremented by 1 and this element will be removed. Once again when you are removing this element by using the dequeue, 30 will be removed and front is going to the front plus 1. Next time 40 will be removed and the next one 50 will be removed. Like this, from the front of the queue you are removing. So that's why if you see the conditions that we are having, once again here also we are having the three conditions. The three conditions are: when the queue is empty, you can't remove anything. Suppose if you are going for the taking a ticket in a queue, if no one is there, to whom they will give that one? Queue is empty. Or suppose consider that only one person is there in the queue. So he is the first person and he is the last person. If the ticket has been given to that particular person, no one will be present in the queue. That means front equal to rear equal to minus 1 that we will be getting. Sorry, here it is minus. Suppose if the front is equivalent to rear, that means only one person is present in the queue. At that particular person, front equal to rear equal to minus 1. This is not 0, it is minus 1. In all other cases, you are making front equal to front plus 1. See here, if the front equal to minus 1 or front is greater than rear, the queue is underflow. No element is present in the queue. Otherwise, what we are doing, if the front is equivalent to rear, front equal to rear equal to minus 1. In all other cases, the front is made as front plus 1. This is the way in which the array implementation is made. In a similar fashion, now we are seeing the linked implementation of the queue. The linked implementation of the queue is also having the same conditions. Instead of minus 1, we will be having the null. The front and the rear will be pointing to the null. Whenever you are inserting the first element called as 10, this is the new node that we are creating. The new node is the first one and the new node is the last one. Front pointer points to this new node and rear pointer points to this one. And enqueue20, you are going to insert an element after this one. So that means the rear is incremented to the next position. That means this is, if you are considering this as a new node, rear of next is pointing to this particular new node and this will become as the rear. When we are inserting the 30, 40, the same type of activities will be happening. The front will be pointing to the starting node and the rear will be pointing to the ending node that we are having. See the thing that we are doing. This is the element that we are having. Suppose this is the new node. Rear of next is pointing to the new node and this new node will be becoming as the rear. So what are the two operations that we are implementing? Rear of next equal to new node and the new node is rar equal to new node. These are the things that we are doing. In the linked implementation, there will not be queue overflow condition because any number of elements you can insert. We are creating the new node, and if the front equal to null and rar equal to null, the queue is empty, the linked list is empty. At that particular moment, our new node will become as the front and the new node will become as the rar. That is front equal to rar equal to new node. Otherwise, you are inserting at the end. That means rar of next is pointing to the new node and the new rar is the new node. Now we'll see the function for inserting an element into that one, that is enqueue operation. We can also write it as a insert operation. We are taking the two pointers, pointer and the new node. We are asking to enter an element to insert into the queue. We are reading the number and I am creating the new node. The new node, by using the malloc function, I am creating new node of the data equal to number and the new node of next equal to null. This is all nothing but creation of the new node, and we are checking if the front equal to null. So there was no need that we have to check the rar is also equivalent to null. If the front is equivalent to null, the meaning is that the queue is empty. In such situation, our new node will become the front and the new node will become the rar also. In all other cases, we are inserting at the end, that is rar of next is pointing to the new node and rar equal to new node. These are the operations that we are implementing on this particular insertion. That means whenever the queue is empty, we are making front equal to rar equal to new node. Otherwise, you are inserting after the rar. That is rar of next equal to new node and the rar equal to new node. And the next operation that we are having is dequeue operation. In this dequeue operation, suppose consider that I want to remove an element from this particular queue. So dequeue operation removes the node that is pointed by the front. That is, front is made as a front of next. So now the front is pointing to the 20. So now once again, if you are implementing the dequeue operation, the front is pointing to the front of next. That is, now the front will become the front of next. In such cases, this 20 is removed. Now once again, if you are implementing the dequeue operation, the 30 will be removed. Okay. So this is the way in which that we are implementing. This is nothing but deleting a node at the starting of the linked list. That is, there we are implementing start equal to start of next. Here we are implementing front equal to front of next. For our need, what we are doing is we are making the pointer to point to this front, and front is pointing to the front of the next, and I will be removing this particular node that we will see in this algorithm. See here, if the front equal to null and the rar equal to null, we can't remove any element because the queue is empty. So we are displaying the queue is empty. Otherwise, we are removing the data, that is, we are simply giving a message that we are removing this front of the data. If the front equal to rar, what will happen? If the front equal to rar condition will occur only when only one element is present in the queue. If you remove that particular one element, the front equal to rar equal to null. It will become null. Otherwise, what we are doing, if some elements are there, I am removing the front element. Temporarily, I am placing that front in this pointer, and front is pointed to the front of the next, and we are freeing this particular pointer. This is the way the dequeue operation is implemented. One is the queue is empty condition. Second one is only single element is there. When we are removing that one, queue will become empty. And the last one is some elements are there. We are removing the first element. So this is the way in which we are implementing the dequeue operation. So that is delete operation or the dequeue operation. If the front equal to null, that means queue is empty. Otherwise, we are removing the front of the data. And if the front equal to rar, that is only single element is there. If you remove that one, the front equal to rar equal to null. Otherwise, what we are doing? We are placing temporarily the front in pointer. Front is made as a front of next and free of pointer. In the single linked list operations, we are implementing simply start equal to start of next. In place of the start, we are taking here only the front. So this is the way in which we are implementing the delete operation. The queues, they are being implemented in different cases in our computer science applications where we need the purpose of the queues. Everything, like if you are considering in a jukebox, whatever the songs that we are playing, they are placed in a queue. When we are giving the printout, all the documents are placed in the queue. When we are executing some tasks all the tasks are present in the queue.